Alright, we've done an awesome job so far, and in this video we're ready to refine Pac-Man's movements. Now, the first thing that I want to implement is these open exits of the maze. So if Pac-Man goes into one of the exits, it will come back onto the other side. So I'm going to add some extra checks on whether Pac-Man is exiting the maze or not. So here's what I'm going to do. I'm going to bring in an if block, and from the operator section, I'm going to bring in a greater than. And if the Pac-Man's X position is greater than this exit coordinate here, and the coordinate is 210, I'm going to make Pac-Man reset its X position at the opposite end of the maze. So I'm going to set its X to negative 210. So negative 210. This only happens if Pac-Man's direction is right. So I'm going to add this check here. I'm also going to duplicate it for the left direction. So if the X position is less than negative 210, which is the left exit of the maze, it will restart at the right end of the maze. So I'm going to go to operators, bring in a less than block, and if X position is less than negative 210, it will set X to plus 210, which is the right end of the maze. So let me test that. Notice that I'm setting Pac-Man's to its right direction, and it's restarting at the left end of the maze. If I swap directions, Pac-Man restarts at the opposite end. This is good. Now, the next thing that I'm going to do is make Pac-Man cycle its costumes to open its mouth and then close its mouth to create this nom 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 effect. But the problem is that Pac-Man has 5 costumes, and I only want to cycle between these 4 ones. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. That's the cycle that I would like Pac-Man to have. So this is going to be pretty interesting to program. So I'm going to implement a small mathematical trick. I'm going to go to looks, and I'm going to switch costume 2, and I'm going to put it right here at the end of the forever loop. Alright, so switch costume 2, and I want to compute the next costume number based on the current costume number. So if the costume number is equal to 1, the next costume number will be equal to 2. Right? From man 1, I go to man 2. If the costume number is 2, the next costume number is 3. If the costume number is 3, the next costume number is 4. But if the costume number is 4, the next costume number is going to be 1. So I'm going to write a small mathematical trick. I'm going to go to operators, and I'm going to bring in the mod operator. And I'm going to snap the costume number inside the first space. So the costume number, mod, and I'm going to put in 4 here. And finally, I'm going to add 1. And I'm going to explain what this block does in a second. So costume number, mod 4 plus 1. If the costume number is 1 mod 4, remember, is the division remainder from 1 to 4. So 1 divided by 4 has a quotient of 0 and a remainder of 1. 1 plus 1 is 2, which is the next costume number. So if the costume number is 1, this whole operator will give me back 2. If the costume number is 2, something very similar. 2 mod 4 is equal to 2, plus 1 is equal to 3. If the costume number is 3, 3 mod 4 is 0, plus 1 is 4. So if the costume number is 3, the next costume number is 4. But if the costume number is 4, 4 mod 4 is equal to 0 because the number 4 divides by 4, and then plus 1 is equal to 1. So if the costume number is 4, the next costume number is going to be 1. So this mathematical trick does exactly what I want. So I'm going to snap it here in the switch costume 2 block. Now I'm only going to make this switch if Pac-Man is actually moving. So if the direction is not equal to that stay direction, which makes Pac-Man stationary. So I'm going to wrap this switch costume in an if block. So if, and I'm going to bring in a not operator, and in the diamond shaped space I'm going to copy this equals operator. So if not direction is equal to stay, which is the stationary condition for Pac-Man, I'm going to switch costume to this formula over here. And originally, I'm going to make Pac-Man stay. So let me hit the flag and see the effect of that. So flag, and if I'm moving towards the right, notice that Pac-Man is moving currently left and right, so Pac-Man is not turning around, but Pac-Man is switching its costumes a little bit too fast. So I'm going to make Pac-Man switch its costumes at every other step instead of at every step. So for that, I'm going to create a small variable that will tell whether Pac-Man should change its costume. So I'm going to create a variable. I'm going to name this change costume. And I'm going to make it private to Pac-Man, so check for this sprite only. Now, initially, this change costume variable will have a value of 0. And I'm going to cycle this variable between values 0 and 1. So I'm going to set this change costume to 0. And if the direction is not equal to stay, I'm going to set the change costume variable to another value, and I'm going to compute this another value with another mathematical trick. And here's how I'm going to do it. I'm going to go to operators and bring in the mod block, and I'm going to add another plus block. So something plus something mod something. And here's how I'm going to do. I'm going to bring in change costume in the first space. I'm going to add 1, and I'm going to do mod 2. So here's how this block is going to work. If change costume is 0, 0 plus 1 is 1. 1 mod 2 is equal to 1. So if change costume is 0, I've swapped change costume to 1. If change costume is 1, 1 plus 1 is equal to 2. 2 mod 2 is equal to 0. So I've basically swapped between the values 0 and 1. So I'm going to bring this block inside. Now I'm going to make the switch to the costume only if the change costume variable has the value 1. So I'm going to go to control and I'm going to wrap the switch costume block in an if block. So if the change costume variable has the value 1, I'm going to switch the costume. So I'm going to go to operators, bring in an equal sign, and in the first space, I'm going to bring in change costume, and in the right space, I'm going to say 1. So if the direction of Pac-Man is not equal to stay, I'm going to set the change costume variable to this formula here, which swaps the values between 0 and 1. And if the value of the change costume variable is 1, then I'm allowed to switch Pac-Man's costume. Let me hit the flag and see the effect of that. So flag, and Pac-Man starts at the center. Notice that Pac-Man swaps its costumes much less often now, which creates the more natural Pac-Man feel. All right. Let's also make Pac-Man turn around when we change Pac-Man's direction. So when we set the direction to up, down, left, or right, we can also change Pac-Man's orientation. So I'm going to go to motion, and I'm going to put in this point in direction. So if the direction is up, the direction is going to be 0. If the down arrow is pressed, the direction is going to be 180. If the left arrow is pressed, then the direction is -90. And if the right arrow is pressed, the direction is 90. So if I hit the flag now, notice that Pac-Man is able to decide on its actual direction of the sprite. Alright, that's awesome. So we've made Pac-Man movement almost complete. Now the last part is also going to be the most challenging, and it's time I showed you the collision costume. That's because at this point we are going to restrict Pac-Man's movement to be only inside the maze. So for this purpose, I'm going to go to the costumes and I'm going to select the collision costume, and I'm also going to point Pac-Man in direction 90 so that it's in its natural direction. And I'm going to go to the empty space into the sensing section, and I'm going to bring this diamond-shaped color is touching color block. Now, the difference between the color is touching color and the simpler touching color is that this more complicated block is asking whether this color of my sprite is touching this other color of the environment or the other sprites. So whenever Pac-Man is going to be able to change its direction, I'm always going to be asking, look at this one, is the color of this cross touching the color of the wall, or this orange cross touching the color of the wall? If it does, then Pac-Man will not be allowed to move in that direction. So here's how I'm going to program that. I'm going to bring in an if block, and I'm going to say, if the intended direction of Pac-Man is up, but the purple cross touches the inner color of the wall, then I'm going to set the Pac-Man's direction to stay. So I'm going to block Pac-Man from moving. So I'm going to go to operators, and I'm going to bring in an AND block. So if the direction is equal to up, and I'm going to bring this color touching color, and I'm going to select from the eyedropper the color of the purple cross. So if the purple cross is touching, and I'm going to pick the eyedropper again, the inner color of the wall, so I'm going to pick very carefully this dark blue color of the inside of the wall. I'm actually going to go around here because it's clearer. All right. So if the purple cross is touching the dark blue color of the wall, I'm going to set the Pac-Man's direction to 0. That is to stay. So I'm going to set direction to stay. Now I'm going to duplicate this 4 times for all the directions. So I'm going to duplicate it, and then I'm going to duplicate this again. So if the direction is up and purple is touching the wall, then set its direction to stay. If the direction is down and the color, and I'm going to pick this orange cross, and if the orange cross is touching the same color of the wall, I'm going to set its direction to stay. If the direction is right, actually let's pick left. If the direction is left and the left cross, the green one, is touching the color of the wall, set its direction to stay. And if the direction is right and the color of the red cross is touching the wall, that set its direction to stay. Before all of that, I'm going to change Pac-Man's costume to the collision costume. So switch costume to collision so that we can have these checks, these crosses. All right. And I'm also going to point Pac-Man in direction 90 so that these crosses aren't flipped around. Finally, after all these checks, I'm going to switch Pac-Man's costume back to Man 1. So now all I have to do is bring this entire script and put it right here. So notice the position here. We're putting the script inside the if block that is going to change whether Pac-Man can change its direction. All right. So make sure that this collision detection mechanism is inside that if block. Now let me click on the flag and see the effect of that. So Pac-Man is there. It's not orientated in the right direction, but notice that when it hits the wall, it stops, which is exactly what we wanted to do. We are restricting Pac-Man to move only inside the maze. This is amazing. So let's fix that direction thing because it's quite easy to fix. That happens because our collision detection mechanism only points Pac-Man in direction 90, so we need to update Pac-Man's direction in the movement part. So we are going to bring these point in direction blocks, and we're going to snap them inside the movement script. So if direction is up, I'm going to change Y by speed and point in direction 0. If the direction is down, change Y by whatever and point in direction 180. And then for the left direction and for the right direction. And now Pac-Man will move in the right direction now. So if I hit the flag, notice that Pac-Man is pointing where it should. Alright, so this is great. We've restricted Pac-Man's movement to be only inside the maze. This was a tough job, but I'm proud that you did it. Join me in the next video as we will start programming Pac-Man's enemies to be intelligent enemies to come and get me. So join me in the next video.